My friends, in my 200 3D CAD models in FreeCAD series, today I want to work on exercise 148, which looks really similar to what I did yesterday in 147. So let me open it up, take a look at it. So this is where I left at 147, and I think I can modify this to build 148. I can do that. Should be easy. Well, not that easy, but it should be simpler. Okay, what I want to do is I see these dimensions are different, so at least we can reuse this part. So let's go ahead and there's a lot of constraints. So this part we are getting rid of, right? Okay, we're getting rid of this part, and then so we're only keeping up to this, so maybe this part too. Okay, and I'm gonna go ahead and make this hexagon part suppressed and take this circle back, and that would be diameter 12. Now it is 7.5, so it will be 6 instead, and outside diameter is 9. Radius is 9.6. Okay, so we got that part taken care of. This total width is 14.4, which is 18 here, so 14.4 makes sense. And this radius will change as well. It will be radius 4. Okay, let's make this horizontal. All right, and what else? So this is 19.2, which is 24 now. So let's go ahead and make it 19.2. And how about this 22.2? That is 17.8. It's possibly the same, just different values. All right, now we have a lot more things to work on this side. And first of all, this radius is 6.2, this outside. So this is going to be 6.2. Maybe apply some tangency. Okay, and move it backward. And because that center is actually 49.9 millimeter away, so from this center to this, the distance is 49.4. Was it? Actually 45.9. Okay, now we will have to build another arc here, and I want to say these two are equal, and then I want to place these on the same vertical plane, so will be these two. Okay, so this dot, okay, actually I want to do it on this one. So this distance is, it's given from this center. These two is 3.6 millimeter away. 3.6, pretty close. And this is 10 millimeter down from the origin. I want to go ahead and apply some tangency between these two portions. Okay. say these two lines will be equal. Right. Now the fun part. There will be center and then make 4 arcs. Just like that. Don't know if these two are coincident, so go ahead and make it coincident. And then I'm gonna go ahead and make some dimensions on this. So the inside one is 16.7. And then the outside one is 21.5. And that center is 67.5 millimeter away from this center. Okay. Now I can go ahead and draw this line, which is not a line, which is radius of 15.7. I'm gonna go ahead and say 15.7 radius, and then connect it. This center is 19 millimeter away from this center. 19. Okay, cool. Now I can go ahead and take these 3 and mirror it over on this side. Okay, so again, these 2 red, nothing to worry about. I'm gonna go ahead and make these 2 coincident, and there are too many red lines here. Okay, now what are we missing? Okay, that was the only thing missing. So I took all of these points and then hit C on the keyboard, and that's a fully constrained sketch. Marvelous. So we got this inside part done. What it looks weird is this small end. Let's go ahead and fix that. The only thing to fix that is maybe hide this part, right? And then bring it over. So here I want to say take this whole thing down, bring our circle back, and then take this point and take this point, make it coincident, and then update the radius, obviously. So this is going to be radius, so diameter 12, and then the outside is going to be diameter 9.6 times 2. Okay, and what else? The distance. Okay, why did it move again? It's not taking, for some reason this dot and this dot are not taking it in. So what we have to do is we have to place it on this line, right? And then make the distance, spell it out as 17.8. Okay, so that reference, and that's why I actually don't like reference that much. Try to make them, as independent as I can between 2 sketches. There it is. That's our object. The way we did it in what 47, we could still make this a like 6 side range, right? And on this one, we can say this is something to hold the cylindrical side. We can even do an FEM analysis to show how it will bend if we apply some pressure and then having a cylinder in the middle. It will be fun. Let's give it a try. So let's take it to FEM, and then I want to apply a container, analysis container, have a solver in there, and then add a material, say steel something. Okay, and then I want to fix this part, right? And then apply load on these two sides. So there will be force load, and add this, right? And it will be reverse direction, and say we are not looking to like a massive amount. Let's say 250 Newton. We'll come back to change it if the deflection is not too much. All we are interested in the deflection, nothing else. So I want to add this phase, apply the same load, 250 Newton, and hit OK. And then take this model and go to Gmesh and apply first degree and apply. So that's the combination works best for me. Gmesh and first element order on objects like this, like with a lot of curvatures and corners and things like that. All right, that mesh worked. Now all we have, okay, I have two solvers, don't know why. Double click on the solver, write the INP file and run calculix. Give it a minute to do its thing. Actually it was fairly quick, and it closed. Looks like it worked. So I want to go to the CCX result, right? And then take a look at the displacement. It's going to move 1.2 millimeter. That's not that much, but let's take a look at the animation, and that's all I wanted to see actually. See, that's how it will squeeze in. So if we can use this model as a type holder, maybe slider maximum at 1. Now we can see actually the total deformation. So it's pretty small deformation for 250 Newton force on both ends, but you get the point. That was a little fun experiment. Hopefully you liked it. Thank you for watching. If you have any question or comment, please let them know in the comment section below. I will see you in the next one then.